6.2 Measure of Location, 6.3 Measure of Dispersion. Learning outcomes. At the end of this lesson, students should be able to find and interpret the mean, mode, median, quartiles, and percentile for group data. Find and interpret the variance and standard deviation for group data. And find and interpret the Pearson's coefficients of skewness. Student can read by yourself for the definition below. Now, we look at to the formula for group data. First, for mean. Mean is sum of fx over with sum of f, where x is a midpoint of the class and f is a frequency. For mode formula is LB plus within bracket of D1 over D1 plus D2 times with C, where LB is a lower boundary for the mode class. D1 is a difference between mode class and the frequency for the previous class. D2 is the difference between mode class frequency and the class frequency after the mode class, and C is class width. For median, quartile, and percentile, we use the formula for PK. P stand for percentile. The formula is LK plus in bracket of n times k over 100 minus fk minus 1 over fk times c, where LK is lower boundary of the percentile class, n is a number of the data, fk minus 1 is cumulative frequency before the percentile class, and c is a class width, and fk is a frequency of the percentile class. The formula for variance and standard deviation is the same like as the formula for variance and standard deviation for ungrouped data. Example 9. The following frequency table shows that the consultation time rounded to the nearest minute needed by a doctor for a patient in a day. Given consultation times in the form of class interval, or we call as a class limit. This one is a lower limit and right side is upper limit. If the value of upper limit does not equal to the lower limit for the next class, we call as a class interval or class limit. Then, number of patients we can write as a frequency. So here, to determine the mean, mode, and median, first we find the class boundary. Class boundary is determined by finding the midpoint of the upper limit for one class and lower limit for the next class. So the midpoint that we have is 9.5. Then for the next value 14 and 15, the midpoint is 14.5. We write for another class boundary. For the first class boundary is 4.5 to 9.5, and this one is 14.5 to 19.5. If this value or upper limit and lower limit for the next class is equal. So this one we call as a class boundary. Then for frequency, we write as a given 5, 8, 9. Then for class mark is determined by midpoint of class limit. So 5 and 9, the midpoint is 7. 10 and 14, midpoint is 12. 15 and 19 is 17. For the next column, we find for fx. Fx means frequency multiplied by class mark. So we have as a given. Okay, for the next column, we create for fx squared. Fx squared means we square for value of class mark or value of x, then multiple with f frequency. So here we get as a given. For the last column, we create for capital of F means cumulative frequency. Cumulative frequency we determine from the frequency. First cumulative frequency is 5. For the next, we total up for the frequency for the next class. So we have 13. And the next value is 13 plus with 9 is equal to 22. Then 22 plus with 3 is equal to 25. And 25 plus 5 is equal to 30. After we fill in all the values in the table, now we total up for F. So here is sum of F. Then for Fx, here is sum of Fx. And last one is total up for Fx squared, we get sum of Fx squared. To determine mean is equal to sum of Fx over with sum of F. Sum of Fx is equal to 485 over with sum of F is equal to 30 and mean is equal to 16.17. Then to determine mod, we use the formula LB plus D1 over D1 plus D2 times with C. Before we substitute the value of LB, D1 and C, now we try to find the model class. Highest frequency is 9. So this one is a model class. So we write as a model class here. Then substitute LB lower boundary for the mod class is 14.5 plus D1. D1 is a difference between frequency of mod class and the previous frequency. So the difference is 9 minus 8 is equal to 1 over with 1 plus with D2 is difference between model class 9 and the next class. So 9 minus 3 is equal to 6, and C is a class width. So class width is determined by upper boundary minus with lower boundary 14.5. So the answer for mod is equal to 15.21. Median is equal to P50. First, we determine the observation of median. So the median is the n times k over 100 observation, or it is equal to n is 30, k is 50 because of p50 over with 100 observation. So the median is 50th observation. Now we determine the 50th observation on the table. So 50th observation is here, so we highlight for the median class. Median formula is LK plus with n times k over 100 minus fk minus 1 over with fk times with c. Substitute LK is lower boundary for the median class is 14.5 plus with n times k over 100 is equal to 15 minus fk minus 1 is cumulative frequency before class median 13 over with frequency for the class median is 9, so times with c is 19.5 minus 14.5, or c is equal to 5. Then we find the value of median is equal to 15.61. Calculate the Q1, Q3, P20 and P90. First, we determine the observation of Q1. So the Q1 is the 30 times with 25 because of Q1 is equal to P25 over 100 observation is equal to 7.5 observation. For 7.5, it is located here. So we highlight for the class of Q1 here. By using the formula of Q1, so Q1 is equal to lower boundary for the class Q1 is 9.5 plus with n times k over 100, the value is 7.5 minus cumulative frequency before class Q1 is 5 over with frequency of the class Q1 is equal to 8 times with size class or C is equal to 5, means 14.5 minus 9.5 is 5. So the Q1 is equal to 11.06. For Q3, the Q3 is the 30 times with 75 because of Q3 is P75 over 100 observation. So it is equal to 22.5 observation. 22.5 observation is located on the class boundary 19.5 to 24.5. So the formula for Q3 is equal to LK, lower boundary for the class Q3 is 19.5 plus with n times k over 100 is equal to 22.5 minus with cumulative frequency before class Q3 is 22 over with frequency for the class Q3 is equal to 3 times with C is equal to 5. So Q3 is equal to 20.33. The P20 is the 30 times 20 over 100 observation is equal to 6 observation. 6 observation is located here, so we highlight for class of P20. By using formula, P20 is equal to lower boundary for the class P20 is 9.5 plus with n times k over 100 is equal to 6 minus cumulative frequency before class P20 is 5 over with frequency for class of P20 is 8 times with C is equal to 5, so P20 is 10.125. The P90 is the 30 times 90 over 100 observation is equal to 27th observation. 27 observation is located here, so we highlight for class of P90. The formula for P90 is equal to lower boundary for the class of P90 is 24.5 plus with n times k over 100 is equal to 27 minus cumulative frequency before class P90 is 25 over with frequency of class P90 is 5 times with C is equal to 5, so P90 is equal to 26.5. Question C. Using the answer in A, determine the skewness of the data distribution. From A, mean is equal to 16.17, median is equal to 15.61, and mode is 15.21. From this value, we can write as a mode is less than median is less than mean. Therefore, the distribution is skewed to the right. D. Find the standard deviation, hence find the coefficient of the skewness. First, we look at to the table from A. To determine standard deviation, S is equal to square root of fx squared is equal to 9095 minus 1 over n is 1 over 30. Sum of fx 485, then we square it over with and minus 1 is 29. So standard deviation is 6.576. To find the coefficient of skewness or SK, we use formula 3 mean minus median over with standard deviation. So 3 mean is equal to 16.17 minus median is 15.61 over with standard deviation is 6.576. So SK is equal to 0.255. Example 10. The following table shows the height distribution for a group of students. The height, frequency, and cumulative frequency as below. Find the mean and median. First, we draw the table and write the class boundary. Class boundary is 150 to 155, 155 to 160, 160 and 165 and so on. Then we write frequency 5, 3, 8, 6, 4 and 4. And class mark is determined by midpoint of class limit. So midpoint of 150 and 155 is 152.5, 157.5, 162.5 and so on. Then we determine the fx. We total up for fx. Determine the fx squared. Then we find the total for fx squared. For the last column, we write the cumulative frequency. For mean is equal to sum of fx over with sum of f. So sum of fx is 4940 over with sum of f is 30. Mean is equal to 164.67. The median is the 30 times 50 because of median is P50 over with 100. Observation, so here is equal to 15th observation. From the cumulative frequency, we determine the 50th observation. This is a position of 9th to 60th observation. So 50th observation is located here. So we highlight for class of median. By using formula, median is equal to lower boundary for the class median is 160 plus weight n times k over 100 is equal to 15 minus cumulative frequency before class median is 8 over with frequency for class of median is 8 times with C is 165 minus 160 is equal to 5. So median is equal to 164.375. Find the first quartile, third quartile and interquartile range. The first quartile is the 30 times 25 over 100. Observation is equal to 7.5 observation. By using formula Q1, lower boundary for the class Q1 is 155 plus n times k over 100 is equal to 7.5 minus cumulative frequency before class Q1 is 5 over weight frequency for Q1 is 5 and C is equal to 5. So Q1 is equal to 159.17. Then for the Q3 is the 30 times 75 over 100 observation and is equal to 22.5 observation. Substitute into formula, Q3 is equal to 170 as a lower boundary for Q3 class plus weight 22.5 minus cumulative before Q3 is 22 over weight frequency for class Q3 is 4 times weight C is 5. So Q3 is equal to 170.625. For interquartile range or IQR is equal to Q3 minus Q1. So Q3 is 170.625 minus 159.17 and interquartile range is 11.46. Find 10th and 70th percentile. 10th percentile is P10. So the P10 is the 30 times 10 over 100 observation is equal to third observation. By using formula, P10 is equal to 150 as a lower boundary for P10 plus n times k over 100 is 3 minus cumulative frequency before P10 is 0, frequency for P10 is 5, C is equal to 5, so P10 is 153. For 70th percentile or P70, so the P70 is the 30 times 70 over 100 observation, so it is equal to 21st observation. P70 is equal to lower boundary for P70 is 165 plus weight 21 minus cumulative frequency before P70 is 16 over weight frequency for P70 is 6 times C is equal to 5, so P70 is equal to 169.17. Then D, find the variance and standard deviation. Variance is S square is equal to sum of fx squared is 815337.5 minus 1 over n is 1 over 30. Sum of fx is 4940 squared over with n minus 1 is 29. So S squared or variance is 64.97. For standard deviation, S is square root of variance. So square root of 64.97 is equal to 8.06. E. Find Pearson's coefficient of skewness and hence describe the distribution. For Pearson's coefficient of skewness, SK, the formula is 3 mean minus median over with standard deviation. So 3 mean is 164.67 minus median is 164.375 over with standard deviation is 8.06. So SK is 0.11. By look at to the value of SK 0.11, so the distribution is skewed to the right. Example 11. The table shows the length of 205 leaves recorded by a scientist. A. Find mean and mode. Describe the distribution. Given the length in cm in the form of inequalities less than 0, less than 2, less than 4 until less than 16. So we should know that number of leaves given in the form of cumulative frequency. First, we create a table to write class boundary. No need to write the first class boundary for less than 0 because of the length should be positive, and also the frequency for the first class boundary is 0. We start with second class boundary. For less than 2, the class boundary is 0 to 2. The cumulative frequency is 12. For the next class is 2 to 4, 4 to 6, and 6 to 8. And then we copy all of the cumulative frequency from 12 to 205. And then to find the frequency is, the first frequency is 12. The next frequency is we subtract 36 and 12, we get 24. And then 88 minus 36 is equal to 52. We do the same way and then we get frequency is 34, 30, 24, 15, and 14. Then we determine the class mark, f times x, and f times with x squared. Then we total up for the frequency, sum of frequency, sum of fx, and sum of fx squared. To determine mean is equal to sum of fx over with sum of f. Sum of fx is 1521 over with sum of f is 205. So mean is equal to 7.4195. And then for mode, before we substitute into formula, first we determine the observation of mod. We refer to the highest frequency. Highest frequency is 52, means here this is a model class. Then we substitute into formula. Mod is LB. LB is lower boundary for the mod class is 4 plus with D1 is the difference between frequency of class mod and class before. So 52 minus 24 is equal to 28 over with D1 is 28 plus with D2 is frequency between mod class and class after. So 52 minus 34 is equal to 18 times with C is 2. So mod is equal to 5.2174. Since mod is less than mean, therefore the distribution is skewed to the right. Next, B. Find the standard deviation and coefficients of the skewness. Hence, state the distribution. Standard deviation S is equal to square root of sum of fx squared is 14213 minus with 1 over n is 1 over 205 times with sum of fx 1521, then square it over with n minus 1 is 204. So standard deviation is 3.7885. To determine the coefficients of skewness or SK, we use formula mean 7.4195 minus with mod 5.2174 over with standard deviation is 3.7885. So it is equal to 0.5813. Therefore, the distribution is skewed to the